in today's topic, it's lipids, page number 94 in the old textbook. If you have the new edition textbook, please mention the page number in the chat box. Chapter is lipids, chapter 6, lipids. If anyone is joining late, please help them out with the page numbers. '98 in the new textbook. So lipids, what are lipids? Basically oils, okay, fat, oil, they all waxes, okay. When you break them down, we have lipids. Lipid is the basic structure. So it's also an organic compound, which means it has carbon, okay, and they are insoluble in water. Okay, you cannot dissolve oil in water. So examples like fats, waxes, oils, hormones, certain components of the cell membrane, and they function as the energy storage molecules, okay, and also as chemical messengers. Like hormones are like chemical messengers. Okay, and they when they break down, when lipids are used up, they will give energy as well. Okay, and fats are also a subgroup of lipids. What is the difference between fats and oils? They become solid when the temperature is cold. Okay, and they get liquid when they are heated up. That is fat. Oil, irrespective of the temperature, oil will always stay in a liquid form. Okay, that's one of the main difference between fats and oils. So fats are also a subgroup, a type of lipid, and they are called triglycerides. Okay, so this is the a layer of a membrane, cell membrane, the cell boundary. Okay, cell wall. So cell wall has this lipid bilayer, two layers of lipids. Okay, it has a polar head that is hydrophilic in nature, attracts water. Okay, these round heads of the lipid one layer, these are two layers of lipids. Okay, no, but not facing each other, facing opposite in the they're facing they're in the opposite direction. Okay, so a cell membrane is made up of this lipid layer. Okay, so it's the head end, the polar head end, that's hydrophilic in nature. It attracts water. But the tail end that you see, the zigzag lines, okay, this part, this entire central area, this is hydrophobic in nature. It repels water. Okay. So because of this opposing forces which are together, this makes the cell membrane very selective of how much water should enter the cell and how much water should leave the cells. Okay, if it was only a hydrophilic layer, okay, imagine a situation if the cell membrane was made only of a hydrophilic layer, it will absorb in so much of water the cells may actually burst. And imagine a situation where the hydrophilic area was not there, it was just hydrophobic, the cells will stay dehydrated. Okay, so to maintain that equilibrium, in the cellular structure, cell membranes will have this bilipid layer, okay, which has both hydrophilic, hydrophobic components, and that controls how much water enters into the cell, how much water should leave the cell. Okay, so that is one of the main function of lipids in our body as well. Cell membranes require it. You are made up of cells. Okay, each and every part of your body is made up of cells. So that's the importance of fats in your diet. Okay, your cells require it for their structural integrity. Apart from that, there are other functions as well. We will discuss that in detail. Is it clear to all? So coming to the classification of lipids, you have simple lipids, compound lipids, derived lipids. Okay. So simple lipids like fats and oils. Okay, under them also you have further classification of simple fats, complex fats. Then you have waxes. Okay, that's also another form of lipid. Compound lipids, there is a mineral compound or any other organic compound attached to the lipid structure. Phospholipids, it has a phosphorus layer, mineral attached to the lipid layer. So that is phospholipids. Glycolipids, it has a glucose attached to the lipid compound. Sulfolipids, sulfur is attached to the lipids. That is compound lipids. Okay. Derived lipids, what do you derived means they don't occur naturally. They have to be certain chemical reactions have to take place so that you get these lipids as an end product or as a byproduct. Okay, so alcohol is a derived lipid. All your fatty acids, okay, they are broken down. Okay, long chain fatty acids, short chain fatty acids. Okay, they are broken down. That's when you get fatty acids. The derived sterols, cholesterol. One type of sterol is cholesterol. Okay, sterols are required for hormone production as well. Okay, so that's a derived lipid. Then isoprenoids, terpenoids, carotenoids. Carotenoids, if you remember, beta carotenoid. Okay, vitamin A. So this is a type of isoprennoids. These are derived lipids. Okay. Edema happens when the cells, the water, it leaves the cells and it gets stuck in the extratracheal space in the between the cells. Okay, there is a small space between two cells. When that space gets filled up with water that is leaving from the cells, not and or the water that is leaving the blood vessels. Okay, from any part, this additional fluid can come and accumulate in the extrastacial space. Extrastacial space is not inside the cells, the space between the cells, outside. Okay, so that's when swelling happens, edema happens. Okay. Sterol, for example, cholesterol. An example of sterol is cholesterol. So, chemical composition. So, triglycerides, fats. Okay. Another name for triglycerides are fats. They are formed by fats. Okay. Which is found in food that you eat, and in human body and animal bodies we have fat deposits in our body. Okay, plants don't have fat deposits. Okay, but the human body, animal body, we have fat deposits, and that in that also fat is stored in the form of triglycerides, like in adipose tissues and all. Fats are stored in the form of triglycerides. So triglycerides, you require three fatty acids. They get into a reaction with glycerols. That's how you get triglycerides. Okay, they are the esters of glycerol and fatty acids. When glycerol and fatty acids combine in a chemical reaction, you get a triglyceride. Okay, and uh, the structure, the length of the triglyceride, it depends in varying degrees. Then you have fatty acids, saturated fatty acid, unsaturated fatty acid. Okay. So, what do you think is a better option? Is it saturated fatty acid or unsaturated fatty acid? Yeah, unsaturated fatty acids is the healthier version. It does not mean that unsaturated fatty acids are completely bad. Okay. See, esters are another organic component. Okay. Esters are like when you replace a hydrogen atom, okay, with something that is organic in nature, or any base or alkaline, something that is alkaline in nature is replacing hydrogen. That's when you get an ester. Okay. For example, if you see here the hydrogen atoms of glycerol here, OH, you see OH here. Okay, this is what it makes this substance a glycerol, alcohol. Okay, when OH is added, this H is replaced, this hydrogen atoms is replaced by these three structures. Okay, this entire organic structure is replacing hydrogen atoms. Okay, so that's how you get a triglyceride, which is an ester. Okay. So here fatty acid, another organic component, is replacing the hydrogen atoms. So you are getting a ester. So why unsaturated fatty acid is healthy and saturated is non-healthy? So imagine a situation, okay? You have to stack up fatty acids on each other, one on top of the other. Which do you think is easy to stack up? This bent unsaturated fatty acid, or this straight line of saturated fatty acid? Which do you think can stack on each other up at a molecular level, like building blocks? Yeah, it is a saturated fatty acid. You can look at the structure here, it's a straight line. Okay, you keep another saturated fatty acid on top of it, it will happily sit on top of it without any movement. Okay, but unsaturated fatty acid, because of this double bond, it has a bend. Wherever double bond is there, in that area it will bend. Okay, that area it will bend. Because of this bend in its structure, it cannot sit on top of each other in a natural way. Okay, so that's the reason why saturated fatty acid is considered unhealthy, because it is stackable. The molecules can sit on top of each other in such a way that it can get accumulated. Okay, when things sit on top of each other, it's difficult to move them, they get heavier. Okay, that they become dense. Okay, they get heavier to move. Okay, so that's the reason why saturated fatty acid, a food that is high in saturated fatty acid, a diet that is high in saturated fatty acid, will cause cholesterol issues, atherosclerosis, blockage, cholesterol based blockages in blood vessels, because saturated fatty acids can easily sit on top of each other. Okay, unsaturated fatty acids are bent in their structure, they can't sit on top of each other, so they keep themselves in a very small molecule, and they travel through the blood circulation without getting accumulated. Okay, so that is one of the reason why saturated fatty acids in comparison is considered unhealthy. But a healthy diet should have substantial amount of saturated fatty acid as well. Okay, for example, 5 to 7% of the energy that you get on a daily basis, 5 to 7%, that's it, that can come from saturated fatty acid. Okay, remaining 15 to 30% of energy can come from unsaturated fatty acids, essential fatty acids, whatever. But at least 5 to 7% of energy you can derive from saturated fatty acid without causing much harm to your health. Okay, so is it clear the concept of saturated and unsaturated fatty acid? It's because of this double bond. This double bond is not breakable also. Okay, it's very difficult to break a double bond. These single bonds that you see in a single straight line of the saturated fatty acid, it can be broken up easily with the enzymes that you have in your stomach, the acid that you have in your stomach. Okay, they can break these small bonds very easily. Okay, and they become more small particles, and they become low density fats, though low density lipids, LDL, okay, because now their density reduces when they are broken down. Okay, they become LDLs, and LDLs are harmful for health. Okay, but unsaturated fatty acids, it's difficult to break the double bond. So they usually stay longer in their size. Okay, in their molecular size, they are longer, they are bent, so they don't stack upon each other. And because of the density, the long structure, they keep moving. Okay, they don't break off and displace and get stuck in various parts of the blood circulation. Is it clear to all about saturated and unsaturated fatty acids? Examples are there. The oils that are the examples of saturated fatty acids, okay, like butter, coconut oil, okay, ghee, they all are saturated fatty acids. Unsaturated fatty acids, uh, fish oil, olive oil, mustard oil, canola oil, all the seed oils, vegetable seed oils like sunflower, safflower, they all come under unsaturated fatty acids. Coconut oil is considered as a fat, okay. It has the name oil in it, but it acts as a fat because it it gets hardened, okay, in a cold temperature. Then you have medium chain fatty acid. Even if it is a saturated fatty acid, medium chain fatty acids are relatively good for health. Okay, MCTs, they are relatively good in health, from a health point of view. And coconut oil is also a medium chain fatty acid. Okay, if you are using virgin coconut oil and all, it's good. It's a good quality medium chain fatty acids, MCTs. These are natural MCTs. Okay, you have industrial MCTs prepared for health purposes. Okay, you can use that also. Naturally occurring MCTs, it's coconut oil, the malai in milk, okay, palm kernel oils, these are naturally occurring MCT oils, and they are usually used in people who have cardiac issues, okay, who have fat malabsorption, any immunodeficiency syndromes, cancer patients. Okay, for them, MCT oils are prescribed to be used in their day-to-day diet. Okay, so that is medium chain fatty acids. Medium chain means the length. Okay, the length of the carbon compound of the fatty acid. So at least 10 to 14 carbons they will have. Medium lengthwise, they will have 10 to 14. A short chain fatty acid is just 5 to 6 carbon compounds. Long chain is like 18 and above. Okay. And they are short enough to be soluble in water, and they require less bile salts, okay, for breaking them down to assimilate them. And they are long enough that they don't get stuck in the blood vessels, they keep circulating. Okay, so that is the benefit of using medium chain fatty acids. So coming to the fats in body, okay, see, MCT, it's not about just MCT, it's the mix of oils that you use. Okay, it's the mix of oil that a person uses. Even if you are using MCT oil as a main source of fat, okay, it's better to use other types of oil as well in your diet rather than depending on just one type of oil. Okay, it's better to have a variety of oil in your diet. Okay, so maximum, if you have a sedentary lifestyle, if you're prescribing for a woman, okay, sedentary lifestyle, 25 grams of fat, not more than that. For a man, 30 grams of fat per day. And within this 30 and 25, you can divide how much MCT you want to use, how much butter or ghee you want to use, what other oils you're using. Okay, if you're taking any fish liver oil capsules or all, you have to calculate. Okay, am I audible to all? So next is fats in body. Your phospholipids. Okay, we have shown the cell membranes layer, phospholipid layer. So this is the cell wall layer. Okay, phospholipids are abundantly present in your body. Phospholipids. It's what kind of lipid? From the classification, if you remember, there are three main classification. So phospholipids come under which classification? They come under compound lipids. Okay, simple lipids, compound lipids, derived lipids. Okay, so they are compound lipids. So phospholipids are found in the cell membrane throughout your body, the cell structure. Okay, and people who suffer from fatty liver, non-alcoholic fatty liver, if you have phospholipid rich diet, it is better for the health. Okay, so lipids, in one way, it is found in each and every cell of your body because it forms the cell membrane. Okay, it forms the cell wall. Okay, cell wall is made up of a lipid layer. Uh, so lipids, fats form the cell wall. Okay, so it's an integral part of human body. And because of this phospholipid layer, cell membrane has this permeability. What can enter, what cannot enter. Okay. Next is cholesterol. You will not find cholesterol in plants. Cholesterol you only find in animal body, human body. Okay, plants cannot have cholesterol. Plants have other sources of fats, but that is in very less amount, like phytosterol and all. Okay, very less in amount because plants, they don't need fat. Okay, they get their regular dose of energy from sunlight they produce on a 24 hours basis. Okay, they get their vitamins and minerals being rooted in the soil. Okay, they don't require fat, they don't require fat storage. Okay, animals and humans, they require fat storage because from an evolutionary point of view, okay, in the winter months, people were not hunting a lot. Animals also go into a state of hibernation. They don't hunt. So they require fat storage in their body to survive through those harsh climates when they don't have access to food. Okay. So that's the reason why human body, animal bodies, they have this capacity to store fat. Okay. And cholesterol is one of the way in which the body is storing fat. Okay. So under cholesterol also you have high density lipids, low density lipids. Okay, high density lipids, the density is more, they are bigger in size. So they keep moving in the circulation. Okay, they can't afford to get stuck somewhere. But it's not true for low density lipids. Okay, we consider them as bad cholesterol. Why? They are so small in size that they will get stuck somewhere. And usually the low density lipids are saturated in nature, so they will get stuck somewhere, and the other molecules of lipids will also stack up on each other. Okay, and because of this stacking personality and this low density, more and more lipids will stack on each other and they will form blockages in the artery. Okay, so that's how cholesterol functions. So people who have cholesterol issues, cardiac health issues or cholesterol issues, have to avoid animal fats as much as possible. No need to completely take it away from your diet. You can indulge in a little bit of ghee and butter somewhere here and there. Okay, not keeping the bar more than 5%. Okay, just a few grams of, if 30 grams of fat you can afford to have on a daily basis. Okay, 2 or 3 gram of butter or 2 or 3 gram of ghee on a daily basis will not cause much harm. Okay, so, but you have to limit yourself from animal fats. People who have cholesterol issues, it's better you follow a more plant-based diet. You can have non-vegetarian options, but don't go for the heavily fatty fishes or pork or beef. Those has more fat content in it. Okay, you can go for the boneless meat. Okay, boneless meat has less fat. If you're consuming eggs, avoid the yellow part, have only the white part that has more uh, protein benefits and it does not have much fat. Okay. But if you don't have cholesterol issues, if you are a normal, healthy human and you don't have any cholesterol based issues, eating a whole egg will cause you no harm. Only if you have cholesterol issues, cardiac issues, there is a history of cholesterol in your family, you have to be uh, you have to minimize the consumption of uh, yellow of the egg. That's it. Okay. Only if you have cardiac issues, cholesterol issues, avoid the yellow part, or there is a history of cholesterol in your family, and you also follow a very sedentary lifestyle and all, or many factors are involved in choosing. Okay, should you have the whole egg or half egg? But usually, if you're having just 2 eggs on a daily basis, and you are a normal, healthy person, you don't have any previous diagnosis of cholesterol based issues, even having 2 eggs per day, 2 whole eggs per day will cause you no harm. Okay. More studies have shown that instead of eating just the white part of egg, eating the whole egg is more beneficial. Nowadays, the studies are showing that aspect as well. Okay. So cholesterol is one way in which fats are in our body, and then ketone bodies. Okay. When you are low on glycogen, okay, your glycogen means the way how body stores glucose. Okay, body cannot store glucose has to be converted into glycogen. Only then your body can store it. Your liver and your muscles, skeletal muscles, can store it. And when body is out of the storage, okay, body ran out of the glycogen stores, now the body will turn to fat. Okay, for energy. And when fat is getting uh, metabolized, the fat that your body has stored in adipose tissues, those fat, when it is getting metabolized, broken down to give energy, ketone bodies are the byproduct of it. Okay, ketone bodies are basically fats. Okay, they are lipids. So they are supposed to give you energy. When the fatty acids present in your adipose tissues, when they are broken down, you get ketone bodies. Okay. So ketone bodies can only happen when large quantities of fats are oxidized. Okay. When you are undergoing starvation, fasting for 3 to 5 days. Okay, when you put your body through such severe conditions, that's when ketone bodies are formed, because fats, when they are getting metabolized in large numbers from every part of your body, wherever adipose tissues have stored maximum fat, everything is getting metabolized. That's when ketone bodies are formed. Okay, this condition is called ketosis, because your blood, okay, it has a lot of ketone bodies in it. It is blood is traveling with a lot of ketone bodies as a result of your starvation. Okay, oils don't have cholesterol. Oils don't have cholesterol. Cholesterol is only found in animal fats, animal based food, even in dairy products, eggs as well. So this condition is called ketosis. When there is a large amount of ketone bodies produced in your body and it is being circulated, it has been carried by your blood, your body is in a state of ketosis. Keto diet is basically this, okay? You are tricking your body into becoming a fat burning machine. When will your body become a fat burning machine? Do you think if your body has enough glycogen stores, enough glucose, will the body become a fat burning machine? If your body has the option of glycogen and fat, the easy way out is glycogen. Your body will not become a fat burning machine. Only when you put your body through a situation in which there is no more glycogen left, there is no more source for glucose, that's when you are pushing your body into a fat burning machine. So that is the idea, the principle of keto diet. Okay. And in a normal person's body also, ketone bodies are there because your body is using carbohydrates and fats. Both are being utilized by your body to give energy. So some amount of ketone bodies will always be present in your body. Okay, about 3 microgram per deciliter per 100 ml of blood. Okay, but from 3, if this ketone bodies jump to 70 to 80, 3, where is 3 and where is 70 and 80? Okay, when the ketone bodies in your blood every 100 ml, if it is more than 70 to 80, that's when you say the body is in a state of ketosis. Okay. Keto diet for long term, it cannot function because the ease of doing this diet, there is no ease of doing it. Eating options are very limited, and also keto diet was not meant as a weight loss diet to start with. Okay, keto diet came into existence to help children, pediatric patients, children who are suffering from convulsions and seizures, okay, myoclonic seizures and all, to help them, help their brain not to be triggered. Okay, for that reason, keto diet was introduced to pediatric patients. And the weight loss, the fat burning theme, the weight loss was a conclusion of the keto diet. And then it was applied to adults as well. Okay, so more than 6 months or more than a year, people have not stuck to a keto diet. We don't have the long-term effects of keto diet, how keto diet will affect a person's body in the long run. We don't know about it. Okay, because anyone who is on keto diet, maximum they can go up to a year on keto diet. Okay, because it's not easy to keep up with the recipes. Okay, for long term, you cannot follow keto diet. It's not meant to be. Even the children who are suffering from myoclonic seizures, um, just for 1 year or 1.5 year or maximum 2 years, the child will be put on keto diet. Then slowly carbohydrates will be reintroduced for these children. Okay, so keto diet is not supposed to be a one and only solution for weight loss or weight management. Okay, for immediate weight loss or to shed a lot of weight within few months. Okay, for those purposes, keto diet with a guided physician's guidance, a nutritionist's guidance. Okay, keto diet can be done. But after, when you have achieved certain weight loss, when you have hit your goal, you have to reintroduce carbohydrates back into your diet, and you have to follow the weight management techniques. Okay, then you have, these are the ketone bodies. Ketone bodies are formed in your liver as well. All the fatty acids from the adipose tissue will come to your liver. Acetyl CoA will convert it into ketone bodies, release it into the circulation. And ketone bodies will go to different parts of your body. Kidneys will remove as much as ketone bodies as possible. That is also ketosis. Ketone bodies in the circulation, hyperketonemia, It will go into your lungs. It will give you a fruity breath. Okay, your breath will have a citrusy, fruity smell to it. Okay, and it will get deposited in your brain as well. So ketone body is getting deposited in the brain, has something to do with children who are suffering from fits. Okay, so this is how keto diet is helping pediatric patients who have myoclonic seizures. Okay, because ketone bodies are going into the brain and they are uh, cutting off certain seizure triggers. Okay, but normal people, they don't require this function of ketone bodies. 60%. Okay, there is no gram to it because the gram of carbohydrate depends on how much energy you are burning. Okay, but in general, for general population, 60% of the energy, whatever is your calorie requirement is, out of those calorie requirements, 60%, and 60% how much gram it is, you have to calculate. That should be the carbohydrate. Okay, in keto diet, just 5 to 10% of energy should come from carbohydrates. In a normal diet, 60% of energy should come from carbohydrates. In a keto diet, 5 to 10% of energy should come from carbohydrates. Then brown adipose tissue. So this is involved, brown adipose tissue is involved in your metabolism. Okay. The more brown adipose tissue you have, a person has, the higher will be their metabolic rate. So naturally, men have more brown adipose tissue as compared to women. Women have three types of adipose tissue: brown, white, and pink. Okay, pink adipose tissue is what you usually gain during pregnancy. It will be used up for lactation. Okay, so that is pink adipose tissue. Okay, that's a fat shift. And also the excess fat that women carry on their upper thighs and hips, that also comes under pink adipose tissue because that will be used up when you are pregnant and as well as when you're lactating. To maintain the lactation, these fat stores will be used up. Okay, so brown adipose tissue, usually it is associated with your metabolism, the way how heat is generated in your body. Okay, or for heat generation as well, brown adipose tissue is required. Brown adipose tissue is active in people who are lean, but people who are obese, brown adipose tissue becomes inactive. And the cells that you find in brown adipose tissue, they have higher amount of mitochondria, means they burn a lot of calories. That's why more brown adipose tissue you have, more calories you will burn on your own without doing any much physical activities, because the cells in the brown adipose tissue has higher amount of mitochondria. Mitochondria, which is the powerhouse of the cell, which means mitochondria is the part in your cell that is producing energy. Okay, so to produce energy, it has to break down something, either glycogen or fat. Okay, and when your cells are blessed with too much of mitochondria, naturally you will not gain a lot of weight. Okay, your body has this innate system in itself to keep the weight away. Okay, so that is the use of brown adipose tissue. It's usually genetic. Okay, the way how you will have, how your body has how much brown adipose tissue, your genetics has to play a major role in it, and your gender. Men naturally have more brown adipose tissue as compared to women. Okay, then fats in food. Okay, so far we have discussed fats in our body, naturally occurring, how fat is stored in our body, how it is used in our body. Now the fats that is found in food, trans fatty acids. World Health Organization has said Keeping trans fatty acids in your diet as close to zero, as close to zero is the best thing you can do for your health, because they have no nutritional value at all. Trans fatty acids, they have, they give you no nutrition, they are just fats. Okay, they are the fats who put you into the risk of developing cardiovascular diseases. Okay, and trans fats are found in all types of processed food, bakery items, okay, cakes, pastries, donuts, okay, wafers, chips, any deep fried food, any highly processed food, they all have, biscuits, cookies, okay, they all have high amount of trans fatty acids. They have no nutritional benefit at all. Keeping them in your diet as close to zero is recommended. Once in a while you can have a treat here and there, but on a daily basis avoid consuming foods that have trans fatty acids. Okay. Then isoprenoids, for example, carotenoid. Okay, carotenoid is also an example of isoprenoid. Okay, it's a lipid based vitamin. Okay, it has a fat based vitamin. It's a fat soluble vitamin. Okay, and also sterols. Hormones have isoprenoids. The cell membrane component has isoprenols. Cholesterol. Okay, then chlorophyll in plants is another type of isoprenoids. Okay, for the plants to prepare their own food. Then essential oils also have isoprenoids. Then visible and invisible fats, even Indian snacks, anything that is deep fried, any food that is deep fried, okay, has trans fatty acids. Okay. See, to increase lipoprotein, increase your protein intake first. Not increase, at least maintain your protein intake. Lipoprotein is low in people who have low protein intake. Everyone has a limit, at least 60 gram of protein everyone should have on a daily basis. Okay. So at least start with there. Keep a target of 60 gram. Try to reach that target on a daily basis. Automatically, slowly, lipoproteins will increase in your system. Okay. And then you have visible and invisible fats. So visible fats is like you go out and you buy butter, you buy ghee, you buy oils, vegetable oil, sunflower oil, visible fat, because you have it in your control how much you have to put in a recipe. Okay, how much ml you have to put, how much teaspoon of oil you have to put, you have it in your control. These are visible fats, okay, which you buy, which you store for cooking purposes. Invisible fat, okay, like you go buy a jalebi or you buy a KFC chicken bucket or something, you know already it has fat. It is not visible to you, but it is prepared, processed in such a way that fat is inherently present in those food. Okay, even if you buy a packet of cookies or biscuits, inherently it has fat. You can't see it. You are only seeing a biscuit, but the recipe has and processed fat in it. So those are invisible fat. Okay, so that's the difference between visible fat and invisible fat. Any form of food, okay, even if it is animal food, animal based food like meat, okay, and also legumes, pulses, they also naturally have fat in them, fat content in it. You can see it. Coconut, grated coconut, okay, it looks like it is coconut, but it is high in fat. Okay, coconut gratings that you use, okay, that is also high in fat. Okay, so those all are invisible fat. So coming to the functions of fat, first is it is the constituent of your cell membrane, cell wall, phospholipids in the form of phospholipids. Okay, Each and every part of your body is made up of cells. Cells are made up of cell membrane and other cell or organelles within it. So even to make a cell, for a cell to be produced, fat should be in your body. Okay. So it's a constituent of the cell membrane. Energy reserve. 1 gram of fat will give you 9 kilocalories of energy. Okay. So it can give you high amount of energy. So that's energy reserve. The way how fat is stored in your body for emergency, if your body runs out of glycogen, fat will be used up to give you energy. Okay, so it's an energy reserve. For absorption of fat soluble vitamins, vitamin A, D, E, K, okay, for all these vitamins to be absorbed and also to be transported, okay, not just absorbed, but to be transported from your intestine to the blood circulation, from the blood circulation to the liver, wherever it has to be stored. For this transportation and absorption, fats are required, okay, in the form of chylomicrons. We'll see that later. Okay, chylomicrons. When we go into the chapters of vitamins, I'll explain you. Then regulator of body functions like uh, to make hormones, fats are required, and hormones are the main regulators of your body. Okay, specifically omega-3, omega-6 fatty acids. Okay, they are also precursors of various hormones. Okay, without these essential fatty acids, hormones cannot be produced. If hormones are not produced, n number of vital functions in your body will be affected. Okay. An insulator to maintain the temperature of your body to prevent heat loss. Okay, because if you know the structure of our skin, okay, what you see when you look at your skin, what you see is the epidermal layer. Okay, under the epidermal layer, the dermal layer is there. Under the dermal layer, you have the subcutaneous layer. That is the fat. Okay, in the subcutaneous layer, you have the fat reserve. Under the subcutaneous layer, you have the muscles, and then you have the bones. Okay, so heat will get trapped under the subcutaneous layer because for heat to cross the fat and leave your body is difficult. So the subcutaneous layer of your body, it preserves temperature within itself because it is made up of fat. It is not easy for the heat. Heat can easily pass through water. Okay, because if you see what, if you remember what is the boiling point of water, if you remember from basic chemistry, what is the boiling point of water? Yeah, it is 100 degrees Celsius. And what is the boiling point of oil? It's approximately about 200 degrees Celsius. Okay, so it's easy for your uh, heat to pass through water and get evaporated into the atmosphere. But it's not easy for the heat to pass through fat surface and get evaporated. Okay, so that's how fat layer in your body, in your subcutaneous layer, prevents the escape of heat. Okay. Next is protector. Okay, apart from the subcutaneous layer, if you see the peritoneal cavity or take any organ, main organ in your body, there is a layer of fat that covers this vital organ, especially in your abdomen, in your abdominal cavity. There is a when you cut open, you will first find the subcutaneous layer of fat, then the muscle, and then you open, you have a fatty layer. Okay, in the peritoneal cavity, that is the visceral fat. Visceral fat is the fat that covers your vital organs to protect the vital organs from any blunt trauma, because this the visceral fat that covers the vital organs like your stomach, intestine, pancreas, kidneys. Okay, this visceral layer of fat can absorb any blunt trauma and not let the blow hit your vital organs. Okay, so that's how it acts as a protector. Okay, but too much of visceral fat is also harmful, and which is very common in Indian scenario. Okay, Indian men, it is very common. People who have pot bellies, it means you are carrying a lot of visceral fat, which indicates that you may suffer from cardiovascular diseases. Okay. The function of a regulator is the involvement of fat in production of hormones, and hormones in turn regulate your body functions. If there is no fat, there will be no hormones and no body functions. Role of fat in diet. First role is the source of energy. We all know 1 gram of fat will give you 9 kilocalories of energy. Then satiety value. The diet that is made with fat, it will keep you full for a longer period of time. Okay. For example, a bowl of salad and a bowl of biryani, both can satiate you for the time being, but after 2 hours, which will make you more hungry? Obviously, salad that does not have enough fat. If you had biryani, you will feel full right now, and even after 2 hours, you will be full. You will not feel like eating anything. But after having the same amount of salad, you will again feel hungry after some point of time. Okay, immediately. That is a satiety value. Fats will make you and feel you full, make you keep feeling full for a longer period of time. Then it is also a carrier for fat soluble vitamins. Okay, within the intestine in the form of chylomicrons, and outside in the blood circulation also, fats are required to pick up the vitamins and take them through the blood circulation, deposit it into the liver. Okay. The amount of body fat that humans should have depends on the geographical regions. Okay. So based on that, you can imagine people who live in mountainous region and people who live in coastal regions. Okay, people who are from the coastal part of India and the mountainous part of India, which of them should have higher amount of fat in their body, higher percent of fat in their body? Obviously, the people who are in the mountain regions, because mountain regions are cold. Okay, mountain regions are cold. You require the insulator function of the fat more. Okay, you will be eating more fat based food when you are in the mountainous region. Okay, because you have to store more fat in your body so that you can prevent heat loss. In coastal regions, you don't have to worry much about fat. There is enough heat. The climate is already hot and humid. You don't have to worry about heat loss. You will worry about heat stroke. Okay, so geography matters. Also, the way how what kind of work you are in, aesthetic work, like if you are into an entertainment industry, generally people who are obese or overweight are not preferred. Okay, you have to be to maintain, so you have to maintain certain body figure. People who are models and all, okay, they have to maintain a certain weight, certain way of look. Okay, so they have to be very consistent with their diet to control the amount of fat that they store in their body. Okay, so all these factors plays an important role in deciding how much fat you as a human should store. Okay, people who live in Antarctica, in the Arctic, North Pole, South Pole, okay, Russia and all, where climate is very harsh and very cold. Okay, so these kind of areas, people have to indulge in high fat diet so that they don't lose their body heat. Okay, not more than 30 grams, as mentioned earlier. 25 grams for women, 30 grams for men, if it is a sedentary work that they have. Okay, if they are rigorously active, you can increase the fat content by more 5 or 6 grams. Then palatability, food that is made using fat is more tasty. Instead of having a raw vegetable, if you have a cooked vegetable or even slightly sauteed vegetable, okay, even just having a plain salad without any dressing, and if you have a salad with a drizzle of olive oil or any cold pressed oil, it gives you more flavor. Okay, it enhances the flavor profile of any food. Fat can enhance the flavor profile of any food. Okay, coming to the digestion of lipids, in the mouth or even in the stomach, no digestion takes place. Okay, certain hydrolysis will take place in the stomach, but not to that extent, because we require this enzyme lipase. Your mouth does not produce lipase, neither does your stomach produce lipase. Lipase is produced by your pancreas. Okay, and it will be secreted into the duodenum. Okay, so there is no secretion of lipase in the stomach and mouth, so no digestion. Okay, the acidic pH of the gastric secretion is also not that helpful for lipid digestion. Okay, certain degree of hydrolysis can take place, but not much. Okay, so the major site of your lipid digestion and breakdown is your small intestine. Okay, in small intestine, in the duodenum, the enzymes, especially the pancreatic enzymes, lipase, will get mixed with your food, and that's where the slow breakdown of the fat will start. Also, bile secretion is also done in the duodenum. So duodenum is the place where the food is getting mixed with bile juices, pancreatic juices, lipase enzymes, mucus. Okay, everything is getting mixed here in duodenum, and as it moves forward into the ileum, okay, sorry, into the jejunum, digestion still keeps continuing because the food is now mixed with all these elements. Breakdown is in the process. Okay, so this is a diagrammatic representation on how you can understand this breakdown. So fatty acids or monoglycerides, okay, when you eat food, it's big globules of fat that is entering. It stays these big globules of fat even in your stomach. Okay, not much change will be there. But as soon as it enters your duodenum is the first part of your small intestine. Okay, it gets mixed with bile salts from the liver. Okay, and because of the action of bile, you can see emulsion will take place. Emulsion means this big particles, big globules of fat is getting emulsified into this small and smaller micelles. Okay, if you know what is micellar water, women will know what is micellar water. Okay, micellar water, micelle plus water. Micelle is fat. Okay, only oil can take off your makeup, but when you look at the micellar water, it looks like plain water. It does not at all look like oil. Why? It has been emulsified. Okay, that fat, that oil also has been emulsified into very small particles called micelles. Okay, women can understand that, those who are using micellar water for makeup removal and all. Okay, if you look at that micellar water, it looks like just like your regular water, but it has very small molecules of oils. Okay, that is micelles. Okay, that's from the name of micelle. That's how you get the name micellar water. Okay, so micelles are these small particles of fats or lipids. Okay, only when they are in the form of these micelles, they can enter your intestine. Your small intestine cannot absorb these big portions of fat globules. They have to be emulsified into micelles. Only then it can enter the small intestine. Okay, so once it is inside the intestinal lumen and it is inside the cell of your small intestine, okay, enterocyte, okay, fatty acids can enter the epithelial cells of the small intestine. And now it has to form a triglyceride. Here, esterification will take place. Okay. Glycerol and the hydroxy atoms will, the fatty acids will join together and they will form triglycerides. Okay, because your body can store fat in the form of triglyceride. Body can store, use fat in the form of triglyceride. Okay, so whatever form of fat, lipids you have eaten in your diet, once they enter the intestine, they will have to convert themselves into a triglyceride. Okay. Now, triglyceride will combine with proteins that are secreted by Golgi apparatus. If you remember basic biology, does anyone remember the name Golgi apparatus? Mitochondria, I guess everyone knows. Nucleus, Golgi apparatus, lysosomes. If you remember these names from your biology subject, from the cell, right? So yeah, Golgi apparatus will produce certain proteins. Triglycerides have to combine, pick up those proteins and form chylomicrons. Chylomicrons, usually they stay in the intestine for a while because chylomicrons have another duty, that is to pick up vitamins, fat-soluble vitamin, and get out of the intestine. Okay, so micelles have to form into triglyceride. Triglyceride with the help of Golgi apparatus will form chylomicrons. Okay, chylomicrons, inside they are a fat globule, outside they have a water soluble part. Okay, so that's how chylomicrons are. It's a combination of water, protein, and fat. Water, protein, and fat. Okay, so because inside there is fat, it can pick up the vitamins, fat soluble vitamins, and get out of the intestine directly into the blood circulation, go to the liver, deposit the vitamins there, deposit the fat wherever it is required, and the body functions will carry on. So this is how chylomicron can enter into a circulation. So fat, as you eat, whatever food you are eating, okay, the molecule of fat that was there in your food is not at all the molecule of fat once it enters into your circulation. It undergoes so many transformation. Okay, in your intestine, it will be forming itself into these small micelles. Okay, you can see the change in the size, big globules of fat into these small micelles. It is ready to, when it is this small, it can be absorbed by the intestine. Once it is inside the cells of your small intestine, it is in the form of triglyceride. Esterification has taken place. Triglyceride with the protein of Golgi apparatus, it will form chylomicron. You can see this structure of chylomicron. Chylomicron is important to carry your fat-soluble vitamins. Okay. So with the vitamins and the fat along with the vitamins will leave your intestine into the blood circulation. And it will take the intestinal blood will take it away from the intestinal portal. Usually it will get deposited in the, it will be getting deposited in the liver. Okay, so this is the transportation, absorption and transportation. Is it clear to all? Next, you have essential fatty acids. So essential fatty acids are the ones which your body cannot store or produce. Okay, you need to have them from your diet. It has to be. Okay, your body cannot synthesize it on their own. So animals, along with humans and other animals, you have to eat specific food that can give you essential fatty acids. Okay, because they are required in certain biological processes in which these essential fatty acids, they can also give you 9 kilocalories of energy. 1 gram of essential fatty acid can also give you 9 kilograms of energy. But that is not the goal. Essential fatty acids are not supposed to give you energy. They are supposed to be used up for biological processes in your body. You don't want to waste your essential fatty acids for energy purpose. They have to be used up in your body for other biological processes. Okay. So you have omega-3 and omega-6. The name how omega-3 and omega-6 came, if you remember the unsaturated fatty acids, do you remember the double bond bend? Do you remember the double bond bend of the unsaturated fatty acids? Okay. So when the bend comes at the third carbon, okay, from the tail end, if you start 1, 2, 3, after 3 carbon, when there is a bend, it is a omega-3 fatty acid. Okay. And if the bend comes after 6 carbon, it is omega-6. And if the bend, that double bond bend is coming after 9 carbons, it is omega-9. Okay, so they are the good fats. This is how the omega-3, omega-6 name has come, depending on where exactly is the carbon double bond bend. Okay, so these are the good fatty acids, omega-3 and omega-6. Omega-3, there is a ratio in which omega-6 and omega-3 should be consumed. Omega-6 can be of a higher amount. Omega-3 should be slightly lower in amount, in ratio wise. Okay. So omega-3, you have 3 different types of omega-3 fatty acids: linolenic, eicosapentaenoic, docosahexaenoic. Okay, these are the different types of omega-3 fatty acids, under which docosahexaenoid, DHA, DHA stands for docosahexaenoic acid. Okay, that's the major component of the phospholipids that are present in the cell membrane of your brain and spinal cord cells. Brain also has cells. The phospholipids that are present in the brain cells, that come from DHA, that has to be made from DHA. So DHA is a very important omega-3 fatty acid when it comes to growth of children, in infants as well. In infants and in preschoolers, toddlers, okay, their diet should have enough amount of DHA, a type of omega-3 which is very crucial for the development of their eyes, eyesight, vision, and their brain development. Okay. Children who didn't get enough amount of omega-3 while growing, it leads to, so it will affect their IQ. Okay. So DHA is a very important omega-3 fatty acid for the development of your brain and vision. And you have to make sure that you get enough amount of omega-3, because all the other fats that you use in your diet, all the other vegetable oils, seed oils, or even pulses, grains, to an extent, they have enough amount of omega-6. You don't have to worry a lot about omega-6. But there are very few food options that you have that are rich in omega-3. Okay, so you have to focus on omega-3 in your day-to-day diet. Okay. So functions of essential fatty acids, they are also energy stores, but we don't use them as energy stores because we have to use them for biological purposes. Okay. Immune health. People who have low omega-3, omega-6 in their diet, they suffer from a lot of immunity issues. The presence, the formation of T cells and B cells by your thymus gland. Again, in that omega-3, omega-6 is important to produce T cells and B cells. Growth and development, especially the growth and development of your brain. Okay, DHA is important. Vision and central nervous system, the health of it, for the health of vision and central nervous system. Even in adults, if you don't have enough amount of DHA, you lack focus, you lack concentration. Okay, your motor skills will get deteriorated. Okay. Then cardiovascular diseases, it can, to a certain degree, not completely, to a certain degree, enough amount of omega and omega-6 and omega-3 can reverse atherosclerosis. Okay, usually if it is in the initial stages, if the plaque or atherosclerosis, if it is in the initial stages, omega-3 and omega-6 fatty acids can reverse them. Okay. Sources we will discuss soon. Specific actions, it can prevent cancer, breast cancer, colon cancers. It has anti-inflammatory effect. If you suffer from any chronic inflammatory diseases or severe acne and all, okay, have more omega-3 based food. Over a period of time, you will see your inflammations are coming down. Even if you have a pimple or acne, it will not stay long because inflammation, it's not increasing the inflammation. Okay. Formation of prostaglandins. Prostaglandins are very important for during periods, during your menstruation, because prostaglandins help contract and relax the uterus. If you don't have enough prostaglandins during periods, the severe pain that you suffer from, the abdominal pain of the uterus being contracted but not getting relaxed, that's why you have severe menstrual pain. Okay, the contraction of the uterus during menstruation is usually what causes pain. So if there is enough amount of prostaglandins in your body, you will not feel the period pain to that degree. There will be slight discomfort on the first day, should not last for more than 3 to 4 hours, but later you can carry on with your day without any issue. Means your body is producing enough amount of prostaglandins. Okay, some women, their entire day they have to, it affects dysmenorrhea, period pains, it affects their daily routine. Okay, so that is a issue. Okay, periods or menstruation should not affect your daily routine. Okay, only then we call it as a normal periods. If because of menstrual pain you are not able to work, you are not able to go to college, school, not carry on with your daily routine, you are bedridden, okay, vomiting, nauseating, okay, if these things are there, it means it's dysmenorrhea. Okay, consume more omega-3 rich food. At least for 3 to 4 months, you will see your symptoms coming down. Okay. Then body's defense mechanism, that is the cell wall, the epithelial cells. Okay. These are the first line of defense of your body. Without proper omega-3, omega-6 fatty acids, you will not be producing healthy quality of epithelial cells, healthy quality of cell membrane. If the quality of epithelial cells and cell membrane is deprived, you are at the risk of developing infections. Any bacteria, any virus can easily cross through your cell membrane and spread the infection. Okay, so that is how your defense mechanism will be affected. Then in your extracellular matrix, it supports various supports the cells which are present in the extracellular matrix for development, movement, shape, and also the biological functions of cell will be maintained. And also the lipids in the cerebral cortex. Cerebral cortex is the part of your brain. Okay. So that the fats that are present in the cerebral cortex are usually omega-3 and omega-6. 80% of the fat which is present in the brain is made up of omega-3. 80% of the fat in your brain is made up of omega-3. Okay. And if that is low, it will affect the degree of your intelligence, your memory, your concentration power, mental alertness. Okay, this can be affected. So these are the specific functions. The deficiency of lipids or omega essential fatty acids would lead to rhinoderma. Here, the skin, the follicles on your skin, hair follicles on your skin, become keratinized. They become hard and dry. Okay. Because again, it is supposed to support the health of your epithelial cells. Hair follicles are also made up of epithelial cells. If and hair follicles, if they're not getting enough amount of omega-3, they become dry and hard because new cells are not formed and old ones are not being replaced. Okay, so the old ones become hard and dry and they poke through the hair follicles like this. So this is a situation called rhinoderma. Okay, very rare absolute deficiency of essential fatty acids lead to this. So RDA, it should be, as I mentioned earlier, the amount of omega-6 you consume on a daily basis should always be higher than omega-3. Okay, it could be 5 part to 10 part is to 1. For every 1 part of omega-3, at least 5 to 9 part of omega-6 should be there in your diet. That is the healthy range. Nowadays, the fat that you buy from market, okay, the refined one, cold pressed one, virgin oils, whatever kind of manufactured oils that you get from from the market, they are prepared in such a way, or the essential fatty acid ratio is maintained in such a way that automatically it meets these requirements. By law, by government, certain food policies, industries are supposed to take care of this ratio. Okay, so you don't have to worry about much. You have to only think more about omega-3 fatty acids in your diet, because omega-6 more or less you are getting from your diet. Okay, omega-3 is the one you have to worry more. Are you able to meet the requirements? And always the visible fat intake for everyone, not more than 50 gram per day. Even if you're an athlete, not more than 50 gram. If you're a sedentary worker, if you're a man, 30 gram is the maximum. 25 gram is the maximum for women. Okay, for the entire human population, 50 gram is the upper limit. Athlete, vigorously working out schedule, whatever it is, not more than 50 gram of fat. You can take the screenshot of this. These are the sources of omega-3, omega-6, and omega-9. Best source of omega-3, fish, fatty fishes, fish oils, algae oils, flaxseed, walnuts, soybean, canola oil. Omega-6 is found in majority of your oils, safflower, sunflower, corn, cottonseed, soybean, evening primrose, blackcurrant seed oil. Sources are mentioned in your textbook as well. Table 6.6, omega-3 fatty acid content. Per 100 gram, how much omega-3 fatty acid you will get is mentioned. Walnuts have the highest based on the list that is given. And 6.6, animal sources of omega-3 fatty acids are given. Vegetarian and non-vegetarian sources both are given in your textbook. You can refer that. So that's all for today. If you have any queries, please mention in the chat.